What really happens when a cruise ship gets trapped in ice and hundreds of passengers find themselves in the sub-zero grip of nature's most underrated traps is not what you think. On January 17, 2026, the Coast Guard cutter Polar Star was patrolling the freezing expanse of the Ross Sea. Commissioned a half-century ago, this 13,000-ton American heavy icebreaker relied on 75,000 shaft horsepower to shatter thick polar ice. Without warning, the radio crackled with an emergency call. The modern expedition yacht Scenic Eclipse II was beset by pack ice 8 miles away. The surrounding ice floes were closing in, actively compressing the yacht's hull with massive force. With nearly 400 people on board and no other heavy icebreakers in the region, the Polar Star diverted from its original path to mount a rescue. The Polar Star swung east at 18 knots, using every ounce of its raw mechanical muscle to slice through the frozen barrier. Breaking through this path meant pushing through heavy Antarctic pack ice that could stop standard vessels dead in their tracks. The crew had to act quickly before the extreme pressure damaged the cruise ship's sensitive propulsion and hull structures. Operating in these freezing conditions demanded that the hull endure relentless friction as the solid white expanse pushed against the ship's side. Standard ships rely on common carbon steel that becomes incredibly brittle and fractures upon impact in sub-zero polar temperatures. The Polar Star tackled this problem using microalloy steel plating reinforced with manganese, nickel, and chromium to maintain flexibility in the freezing Southern Ocean. At the bow and stern, the hull plates measured 1.75 inches thick to absorb punishing blows without failing. Instead of slicing through the frozen barrier like a standard ship, the vessel utilized its weight and angled bow to climb directly onto the ice. The bow climbs onto the ice sheet, relying on gravity and downward force to fracture the solid surface beneath the vessel. Cracking the pack ice required the vessel's 13,000-ton frame to drop through, shatter the shelf, and push forward in a continuous heavy rhythm. The entire process sent shuddering vibrations through the inner bulkheads with every single impact. Relying on 50-year-old metallurgy requires constant monitoring of hull integrity while enduring massive resistance. Navigating a dense ice field is not done from the main bridge. The ice pilot works from the aloft conning station, a heated enclosure perched 10 stories above the waterline. From this high viewpoint, the frozen ocean spreads out like a map. You can see details that are invisible from below, such as dark leads of open water, hidden pressure ridges, and compression patterns where the ice sheets squeeze together. When the ship faces a thick ridge, the ice pilot determines the weakest point in real time. The ice pilot observes the changing color of the pack, guiding the bridge crew through visible fractures in the frozen surface. Reading the frozen water requires a deep understanding of how different ice types behave under intense pressure. The pilot watches the pack shift from gray to deep blue, which indicates thicker, older ice that could stop the vessel. By communicating directly with the helm, the pilot steers the ship along a path of least resistance, keeping the momentum going toward the stranded yacht. Spotting these hazards early allows the engine room to prepare for significant resistance and adjust torque output. Operating in heavy pack ice requires the Polar Star to cycle between forward and reverse constantly to break thick formations. On most vessels, changing directions requires stopping the heavy shafts and spinning them in the opposite direction. This process takes time, wears out components, and puts excessive strain on a 50-year-old powertrain. To avoid this, the icebreaker uses controllable pitch propellers. The blades rotate on their hubs while the shafts keep spinning in one direction at a constant speed. The crew adjusts the blade angle continuously, reversing the thrust while the shafts keep spinning. This setup lets the captain switch thrust from forward to backward almost instantly. In a dense ice field, that immediate response time keeps the ship moving efficiently without causing damage to the aging gears. However, operating this mechanism under heavy friction comes with a trade-off. The internal components take a beating whenever the blades push against hard, dense ice sheets. Handling hundreds of back and ram cycles places tremendous strain on the internal hydraulic hubs of the propulsion system. When the Polar Star finally reached the scenic eclipse II, the situation was highly critical. The cruise ship features an ice-strengthened hull designed to push through smaller flows, not withstand prolonged pressure from a closing ice field. The crew knew that leaving the ship stuck inside the moving pack could deform the plating, much like the pressure that crushed the historic Endurance over a century ago. To relieve this compression, the icebreaker ran a parallel path along the starboard side of the trapped vessel. The ice pilot analyzes the compression vectors, determining exactly where to make the pass to release the trapped vessel. The ice cracked and open water appeared, giving the cruise ship a brief window to use its azipod propulsion and shift position. But this parallel channel offered only a temporary fix. The shifting ice pack moved fast, and the opening began to close within minutes. Because the surrounding flows closed the opening quickly, the captain must utilize a more advanced approach. A single pass only relieves pressure along one axis, and the shifting pack ice continues to squeeze the trapped vessel from other directions. To stop this compression, the Polar Star executes a wide circular braking pattern. This technique destroys the structural integrity of the entire ice field rather than just clearing a single path. Instead of one solid sheet gripping the hull, the ice becomes dozens of separate pieces that can shift and rotate independently. Once those fragments are free to move, the cruise ship can use its own azipods to push the rubble aside. The ship carves a wide ring around the vessel, turning a solid plate of ice into shifting rubble. Executing this maneuver with a 13,000-ton vessel takes immense precision. The conning officer must keep the icebreaker far enough away to fracture the ice without pushing broken blocks into the hull of the stranded yacht. Allowing the passengers to escape without reliance on outside evacuation requires careful extraction from the hazard zone. With the pack broken, the scenic eclipse II follows the Polar Star through 4 miles of brash ice, a slurry of shattered fragments left in the wake. This passage is a race against the freezing temperatures of the Southern Ocean. Without continuous movement, new ice begins to skin over the open channel within hours, creating a new trap. The cruise ship stays close to the icebreaker's stern, matching speed to navigate the narrowing waters safely. The icebreaker maintains a steady speed to ensure the channel does not freeze shut before the cruise ship passes through. The two ships move steadily until the ice thins and the yacht finally reaches open water. The Polar Star immediately turns south towards McMurdo Sound, ready to clear the way for another season of scientific research. The next time you see an icebreaker in action, you recognize the complex engineering and teamwork required to operate in these conditions.